According to the second law of thermodynamics, heat will spontaneously flow from a hot object to a cold object. The amount of unusable energy in a closed system always increases. It is impossible to turn all of the heat put into a system into work. The basic concept behind the second law of thermodynamics is the fact that heat always spontaneously flows from hot to cold. It never spontaneously flows from cold to hot. When using heat transfer to do work, some of the heat always goes to a colder location. This is called entropy. You can never turn all of the heat into work. Heat can be forced to go from cold to hot by applying work. This also reduces the entropy, and thus work can reduce entropy. This is the basis of air conditioners, refrigerators, and heat pumps. Entropy is the measure of a system's thermal energy unavailable for conversion into mechanical work. It is a measure of the disorder or randomness in a system. It is a measure of the equivalent states or multiplicity of a system. In classical thermodynamics, it is mathematically defined as ds equals dq over t. This results in the change in entropy as delta S equals Q over T, where S equals entropy, Q equals heat energy, and T equals temperature. In statistical thermodynamics, it is mathematically defined as S equals K natural logarithm of omega. This results in the change in entropy as delta S equals K natural logarithm of omega 2 over omega 1. Entropy is related to disorder through the multiplicity of a system. Disordered states have far more multiplicity than ordered states, such that omega D is much greater than omega O. This means that entropy D is much greater than entropy O. Since the second law of thermodynamics indicates that entropy tends to increase, it also indicates that a system's degree of disorder tends to increase. The only way to increase a system's order, that is, decrease its entropy, is for work to be performed on the system. Abiogenesis is life from non-life by naturalistic means. Living things are the most ordered and complex systems known to exist. The simplest known living cell is infinitely more organized and complex than the most organized non-living chemical systems produced in a lab. This means that the entropy of a living cell is orders of magnitude lower than the entropy of the same amount of non-living chemicals. This means that abiogenesis goes against the second law's tendency towards increasing entropy. While entropy can be decreased by applying work to a system, no evidence exists for a naturalistic mechanism for such a large decrease in entropy. Without such a mechanism, the second law of thermodynamics suggests that abiogenesis is impossible. The problem is that while the second law of thermodynamics shows that energy applied to a system can reduce its entropy, it does not deal with how the manner in which energy is applied to a system affects entropy. It does not show the difference between construction work and a bomb. Construction work reduces a system's entropy. Bombs increase a system's entropy. The problem is that the second law does not show the difference. An additional principle is needed to show this difference. This is also needed to really determine if abiogenesis is possible or not. In conclusion, heat spontaneously flows only from hot to cold. It indicates that the disorder of a system tends to increase. It indicates that the disorder of a system can be reduced by applying energy. However, it does not show how the way the energy is applied affects the disorder of a system.